Now let's go ahead and write the C++ logic for finding a particular number in an infinite series of sorted numbers. So according to our algorithm that we have discussed, what we will do, we will simply deploy the exponential searching algorithm that we have already discussed, right? So for the implementation also, whatever the functions that we have already implemented, I will try to copy them and make the necessary changes if at all, if they are required. So here I'm going on to the exponential searching.cpp and let me just copy the main function as well as binary search utility function that we have written, and let me just paste it into our implementation. So here, as part of the main function searching infinite sorted numbers, what we need to do, we need to simply call the exponential searching function, and let's just pass the vector of values which we are taking in a variable array, and we will also pass the value that we need to search, and whatever it returns we will directly return that in the end. Okay, remember that while implementing the exponential searching algorithm, we have taken couple of scenarios, assuming that while implementing the exponential searching algorithm, we know how many number of values we had in the sorted array. That is the reason why here we have put some of the checks here based on the size of the array that we are getting. One of them is this while loop check, where we were doing whatever the range that we were right now in is less than the size of the array. At the same time, one of the check that we had is to define the last value for the possible range. There also we were putting the check. But here, since the array that we have gotten is an infinite, has infinite number of values, we can remove these checks. Still the logic would absolutely work fine. Okay, so that is a small modification that you can do or you need not to do, but I prefer it is still a good practice to have, so that the code can be very readable code, as well as if at all if there is an end in the array of values, the logic will handle that. Okay, that is the reason why I'm not removing that. I'll be testing with the similar conditions present in the code. Now to test this, obviously we will have to create an infinite number of values that I don't want to do. We can't do it anyway. So here I have some values here. I'm assuming that these values are basically of infinite number of values. Now let me just go ahead and search the value 20. Now here the value of 20 is present, right? So if I run this, it should basically return the index of 20. So let me just run that and see the output is 12. So if we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 20 is 13th element. That means it is at 12th index. So if at all, if I want to search the value 22, it is not present, right? So I should get -1. And -1 is what we are getting. For example, here I want to search for the value 11. 11 is also not there, right? So now we will run the same code and see the output is -1. If at all, if we pass any value, let's just say I'm just passing 1 is present. So if I run this code right now, see the output is 0, where the value 1 is present. Okay, so in this way, we will basically search for a value using binary search in an infinite series of sorted values. So one thing that you have to remember is, as soon as you read the problem description, you will worry about like, how can I employ binary searching technique for solving this problem? But first of all, we will find the range in which the value might be there. Then we will try to employ the binary searching technique in that range, so that we will be able to find or return -1 based on the availability of the value that we have gotten in the input. Okay, very simple implementation. Thanks for watching. I'll see you in the next problem.